Mitchell Hashimoto, the guy who created Terraform and co-founded HashiCorp, says he's effective at running a background AI agent only 10 to 20% of his working day, and he considers that a massive productivity win. Meanwhile, a Y Combinator startup just launched a tool that lets you run 18 or more coding agents simultaneously, each working on a separate task in isolated Git branches. These two developments landed in the same week, and together they paint a very specific picture of where software development is headed. Engineers as architects, agents as the workforce. Let's get into it. Emdash is an open-source desktop application built by Arne and Rabin, two founders who previously worked on projects at Langdoc and Highlight AI, with one of them having gone through Y Combinator before, with a startup called Sof in the summer 2024 batch. Emdash itself is part of YC's Winter 2026 class, and it just launched on ShowHN with a straightforward pitch: run multiple coding agents in parallel, each one isolated in its own Git worktree, so they never step on each other's code. The app supports over 18 CLI-based coding agents: Claude Code, Codex, Gemini, QN Code, AMP, OpenCode, basically any agent that runs in a terminal. You pick a task, assign it to an agent, and that agent gets its own worktree, which is Git's built-in mechanism for having multiple working copies of a repository at once. While one agent refactors your authentication module, another can be writing tests for your API layer, and a third can be building a new feature from a linear ticket, all at the same time, with zero merge conflicts during execution. Emdash plugs directly into project management tools. It integrates with linear GitHub issues and Jira, so you can pull a ticket from your backlog and hand it straight to an agent. When the agent finishes, you get a diff view to review changes, and you can open a pull request from inside the app. There's also a Kanban board for organizing tasks visually, and a best-of-n feature where you run multiple agents on the same task with the same prompt, and pick whichever result is best. The app runs on macOS and Linux. You can install it with Homebrew on Mac, or download an app image or Debian package on Linux. It also supports remote execution over SSH, meaning your agents can run on a beefy cloud machine, while you manage everything from your laptop. All data stays local on your machine. The only external calls are to whichever AI provider's API you're using for each agent. Up until now, the standard agentic coding workflow has been sequential. You give an agent a task, you wait for it to finish, you review the output, you give it the next task. Even if the agent is fast, the bottleneck is that you're operating one agent at a time. Emdash treats this as a scheduling problem. If you have 10 tasks on your sprint board, why not run 10 agents simultaneously? The Git worktree isolation is the key technical decision here. Other tools that attempt multi-agent coding run into the problem of agents editing the same files and creating conflicts. Worktrees sidestep that entirely. Each agent has a full independent copy of the code base. It's the same principle that lets large engineering teams work on separate branches without blocking each other, just applied to AI agents instead of humans. This also changes the economics of small teams. A 3-person startup running Emdash could theoretically have 15 agents churning through a backlog while the humans focus on architecture, code review, and product decisions. The multiplier effect is significant, especially for teams that are resource-constrained but have well-defined backlogs with clear tickets. The thing to watch with Emdash is adoption velocity. The open-source model means anyone can try it today, and the provider-agnostic design avoids locking teams into a single AI vendor. The real test will be whether the workflow scales. Running 3 agents is manageable, but running 15 requires sophisticated task decomposition and review processes that most teams haven't built yet. If Emdash can help solve the orchestration layer, not just the execution layer, it becomes much harder to displace. Emdash gives you the infrastructure to run a fleet of agents, but infrastructure alone doesn't tell you how to actually work with agents day to day. For that, one of the most respected engineers in the industry just published his playbook, and it took him months of painful experimentation to figure out. Mitchell Hashimoto is the co-founder of HashiCorp and the creator of Terraform, Vagrant, and more recently Ghosty, a popular open-source terminal emulator. He's one of the most influential infrastructure engineers in the industry. And earlier this month, he published a detailed breakdown of how AI agents have transformed his daily coding workflow. a workflow he arrived at after starting as a genuine skeptic. The Pragmatic Engineer newsletter profiled his approach, and his own blog post titled, "My AI Adoption Journeys" laid out 6 stages he went through, from dismissing AI chat tools to running agents as a core part of his development process. The turning point came when he stopped treating AI as a chatbot and started treating it as an executor. He forced himself through what he calls a double-step process. He'd write code manually, then make an AI agent reproduce the same work from scratch, fighting through the friction until the agent's output matched his own quality bar. Today, Hashimoto operates as what he calls the architect. He designs the code structure, decides where state lives, maps out data flow, and then hands execution to agents with specific structural guidance. His rule is simple: if you're coding an agent should be planning the next task. If an agent is coding, you should be reviewing its output. There should always be an agent running somewhere. In practice, he estimates he actually achieves this about 10 to 20% of a normal working day, meaning for roughly 1 to 2 hours daily, he has a background agent producing useful work while he focuses on something else. He uses multiple checkouts of his Ghosty project, Ghosty, Ghosty 2, Ghosty 3, Ghosty 4, running different models on the same task as a competition, then picking the best result. One notable PR he shared showed a non-trivial refactor of Ghosty's macOS split representation, plus 1600, minus 1100 lines, roughly 80% written by AI agents across multiple sessions, at a total cost of about $16. He also treats agents like new hires. When an agent makes a mistake, he doesn't just fix it. He updates an agents.md file in the project repository, with a specific rule to prevent that mistake from happening again. Over time, this builds a set of guardrails that makes the agent progressively more reliable on that specific codebase. The loudest narrative around AI coding tools is that they'll replace developers. Hashimoto's workflow shows something more precise and more useful. Senior engineers become more productive by shifting from writing code to directing code. He still makes every architectural decision. He still reviews every line. The agent handles the mechanical translation of intent into implementation. The 10 to 20% figure is particularly telling. That's not a marketing number from an AI company. It's a self-reported estimate from a skeptic who forced himself through months of painful adoption, and he frames it as the floor, not the ceiling. He's actively working to increase it. If one of the best infrastructure engineers in the world finds even that amount of background agent time valuable, it suggests the productivity gains are real and compounding. His agents.md approach, writing explicit rules based on observed failures, is also worth attention. It's essentially building institutional knowledge that makes agents better over time on a specific project. That's not prompt engineering in the generic sense. It's operational engineering, treating the agent as part of the team and investing in its onboarding the way you would with a junior developer. Hashimoto has been sharing full transcripts of his agentic coding sessions publicly, which is rare. Most developers using AI agents keep their workflows private. As more senior engineers publish their actual processes, with costs, error rates, and honest assessments, the industry gets better calibration on what works. Watch for whether the architect pattern becomes the default for experienced developers, or whether a different model emerges as agents get more capable at handling architectural decisions themselves. The question worth sitting with: if a 3-person team can run 15 agents in parallel, and a single senior engineer gets meaningful gains from just one background agent running a couple hours a day, what does a 10-person team look like in 12 months? The gap between teams that figure out agent orchestration and teams that don't is going to widen fast. If you want to keep up with how that plays out, subscribe. We cover AI and tech news daily. See you in the next one.